Okay, boys and girls, are you ready to see a routing loop? Do you want to see the absolute destruction of a broadcast storm? We're going to show you that today. So I went into a network closet yesterday and I about lost my damn mind. We're not going to say where this networking closet is, but I was in it. Anyways, and they had something like 9 different crappy switches, and the network was giving piss poor performance. And one of the things I did a little video and I showed you folks where it looked like there was a network loop, which was probably destroying the performance for all of the computers on the network. And I'm setting up my lab, or I'm doing the testing for the lab computers for my Linux class tomorrow. And I realized since I have a whole crap ton of computers that are connected to a hardwired switch, I might as well actually show you what a routing loop and a broadcast storm looks like, right? So this important time, I don't know, I've got 5 or 6 computers connected to one of these piece of crap Netgear switches. Now to be clear, a piece of crap is in the eye of the beholder. I bought this for $30, and the reason I bought this for $30 is that I'm going to use it in my classes, right? So tomorrow for the Linux class, we're going to have a Linux server. So we're going to have a hardwired connection for each student. They are going to build an Apache server, a Samba server, and a VSPT server, a couple of other servers. And then right beside it, we're going to have a Ubuntu desktop. And so this is the reason for this is that they can configure the server, and then they can go to the graphical user interface and they can get the idea that command line can give you pretty graphics. That type of deal, right? And so the reason I bought this is because it's $30 and it gives you gig networking, and I'm going to know exactly where all the different cables are going to. But one of the reasons it's $30 is it has no built-in, I hate to say intelligence, but basically rules. So there are no routing protocols in this thing. There's nothing called loop detection. Loop detection is incredibly valuable if you're going to be running a business. And basically what loop detection detects is if one cable is plugged in at one port and then you plug it into a different port on the switch, that basically it doesn't crash the switch. You get a broadcast storm, right? And one of the things I showed you folks in that networking closet yesterday was they have a $3,000 piece of Cisco equipment. It's like a router, a fiber router switch thing. And they also have like a $400 or $500 Ubiquiti console thing. But then they have a whole bunch of these $30 pieces of crap. And I'm about to show you why the $30 piece of crap is bad, right? So if we sit here and we look at the lights, so with these LEDs, basically what these LEDs are showing us is when each port has traffic. So this goes out to our actual router here. And then you'll notice sometimes all the lights blink in tandem, and that's because there's a broadcast going out. A broadcast goes to every single port, but then a lot of other times only a single, right? It's like kind of like that, a single set of LEDs will blink. So anyways, we're gonna go over here to a speed test. Just going to Ookla or whatever. We're gonna hit go. We're going to start doing the speed test and we're gonna see how fast this is. So again, I'm at my house. And, for this 2012 MacBook Pro, we're getting 700 megs, 800 megs, whatever. And look here, again, when we look at the lights, notice this is blinking a lot. This is going to router is blinking a lot, but nothing else is really blinking. They're just on, they're not blinking. The reason is because the traffic is coming in here. So we see the traffic is going out there. So we see the traffic, nobody else is really doing anything. So we come back, we look at this, we get 920 megs. Down, and we're getting, 37 up, which is pretty good. I'm only supposed to be getting 30 here. It's cable internet. That is a discussion for another time. But we got good speeds, network's doing well, the whole 9 yards. And you see how this is. You see how those lights are blinking. Okay, so what I'm gonna do is I'm gonna be a dummy. So the other side of this cable, right? So this cable was originally plugged in this computer. So I unplugged it from this computer, and I'm gonna be a dummy, and I'm gonna plug it in here, right? So we're gonna click that in, And now, okay, so we're not seeing anything. Oh, there we go. See how all of the lights are now blinking in tandem, and they're rapidly blinking in tandem. The reason is because traffic basically comes in, it gets broadcast out. When it gets broadcast out, it loops back into the switch, gets broadcast out, it loops back into the switch, broadcast out, and that's what we call it, broadcast storm. Now, if we come over here, to my computer, it's like, okay, we got 920 before, we got 37 now. What are we gonna get when I click go? And what we're gonna get is it's just gonna fail. it's just gonna fail. If we go here, and go to my favorite site, CNN.com. We're going to say it has trouble finding the site, and the reason is because the network has in fact crashed because of the broadcast storm, and so basically we can't get anywhere. We can't get a speed test, we can't get to CNN, we get this latency error, the whole 9 yards, right? Look at all those lights blinking. All I have to do is unplug this one cable. All the lights go back basically normal. We see this light flashing over here because again, the speed test is coming back. And now it'll go back to, the good speeds that I'm supposed to be getting. So this is what a routing loop is. This is what a broadcast storm will actually do to your network. And so here's the thing. I actually got paid a lot of money back in the day, back when I had my consulting company. I would get paid a lot of money basically to walk in and start unplugging things. One of the big issues you have in the networking world is you have cables that are so long that you don't know where they come from and where they go to. And what'll happen in a real server room is somebody will just see this random ass cable on the ground and they'll be like, oh, that should get plugged in, and they plug it in. They don't realize that the cable's like 10 or 20 feet long and the other side is plugged into their switch. And so actually, I got paid a lot of decent money, especially when networking equipment. This used to be considered high quality networking equipment. The other thing you see, and this is what I think is going on with that company that I looked at yesterday, is if you have a loop like that, but then you have multiple switches, right? So what I showed you yesterday, they had like 8 switches of this quality, and they're all connected willy-nilly. So one of the interesting things you can have there is, see, with this, when the broadcast storm gets as fast as it was, it just shuts the network down. So that's a hard fail. And what I want you to understand is hard fails are good. Right, they're not as good as success. But one of the reasons that hard fails are good is because when something hard fails, you know it's broken and you know you have to fix it. One of the issues, what I showed you with that place yesterday, they had 8 or whatever of these garbage switches that should not be in any business unless you have a lab, and they were all connected together. And so one of the issues you can have is when that broadcast storm happens, and when you have multiple pieces of crappy networking equipment tied together, it can actually end up being pretty slow. So it broadcasts, but it takes a little while to get through the loop until it broadcasts again. It takes a little while till it broadcasts, till it takes a little while. So instead of getting a hard fail where everything shuts down, what you can have with all of these switches connected together is essentially you have this loop that loops through numerous pieces of networking equipment. It actually takes a little bit of time for it to loop through all those numerous pieces of networking equipment. And so therefore it slows, it massively degrades your network without giving you a hard fail. And so that's why if you're going to be buying networking equipment for a business, you always get loop detection. Whatever you do, buy a piece of equipment with loop detection. The other thing that you do is you always buy switches with enough ports for what you need. Again, the business that I showed you yesterday, they simply need a 48 port switch. Having 9 switches is just stupid. It's just stupid. And then beyond that, you need to keep track of all your cables, again, to make sure that you don't actually loop back into the switch. Because even when you loop back into the switch, even if you have loop detection, it won't fail a switch. But that means that's 2 ports. That's 2 ports that you're losing. Think about it. Each port, like if you buy a decent piece of network equipment, and again, not this piece of crap, but a decent one, each one of those ports is going to cost you somewhere between $20 to $50. So if you have a cable plugged into one port and then you plug it into another port, you literally just burned like $100 to do nothing. So keeping track of your cables is also a very important thing. So that's why we talk about cable management. I know for a lot of young people, when you hear about cable management and you start doing cable management, that just seems like the most boring thing in the world. And yeah, yeah, but it's one of those things. It's an incredibly boring task that makes sure your life doesn't get too exciting in the future, if you kind of get what I'm saying. So, anyways, there you go. There's a loop. There's a broadcast storm for you, and yeah, I'm going to send this to the people that I saw yesterday. Be like, this. Anyways, this is why you need to fix your crap. If you like my videos, do make sure to thumb up, comment, share, and the whole 9 yards. And wish me luck on our Linux class tomorrow.